I'm Ian. I'm creating a learning series where I teach myself and others Swift. Teaching helps me relearn forgotten topics, so I'm sharing my notes as videos. Today, we are covering print, var, let, strings, and string interpolation, int, floats, doubles, some calculations, and methods, and computer properties, and yeah. So in the beginning, I do want to explain to myself that in Swift we actually can use a semicolon and it still compiles, though it's not necessary at all. This is a print. Whatever's inside of our print within our parentheses, it will run as long as it's valid. var is it is a variable that it's a mutable variable that you can change over time, and you can use this variable name around your code depending on where it is. So we can actually declare a variable in a couple ways. If it's empty, we can say my var is a string, and we can either have it equal something, or we can have an empty, and we can. So if we just print this out right now, just say hello world again. So it should say actually twice now at this point. Hello world. We should have it twice. If we don't want to initialize it at the beginning, you can just say hello world, and it will give us an error because it's not defined yet. So if we do define it, like I said, you can do it with variables. We can say my var equals, let's just say it's my name, Ian, and it says Ian. Other than that, this is helpful so we don't get mistakes. And so if this was an int, it would have an issue, because now we actually, maybe we're actually looking for an integer in the very beginning, but we actually inputted a string. This is also doable with the booleans, with bool, if it's true or false, a double, a float, and yeah. Another thing is, as I said, in contrast of a variable is you can manipulate the value more than once. So if I actually do say my var is equal to I don't know, John, it will manipulate and it will actually overwrite Ian, and it will become into John. But I do want to keep my name as Ian for now, so it's just Ian. So as I said before, a let, you can actually do the same thing as a let, as in having it undefined in the beginning, but once you define it later in your code, you must realize that it only can be initialized once. So my const string const, this is actually already initialized, so if we do try to change it again, we'll get an error. So just to show you that we get an error, my const is equal to, it's actually given a string lol, and we'll see that it's actually a constant. We really can define it once. If we actually want to make this more valid, we can delete this, and once it is actually we're registering it once the first time, then it'll be lol, and it is valid. If we do try to overwrite it one more time, it'll get an error. Keep note that it's the same data type as in string, and we still get an error because it was already initialized. I do want to talk more about strings here. I think strings are very powerful in its own way. We can actually have another string, and actually, if you do, I do want to show you this. If you do command / you can actually have all this stuff to be commented out instantly. What we can do is make another string, but a really large string. So let's just do, actually, it doesn't matter. Yeah, it's saying it's odd. So we'll just say, I love you. And we can actually do it on many different lines. I love you. So what we can do is saying my favorite number is, and then if we do plus num, we will actually get an error in this because this is an int and this is a string. You have to actually convert this string into a num, but that seems like that's a lot of coding right there. And we can actually do another plus and we continue with our string, and it's still valid, which is, but still, it's a lot of extra steps. What we can actually do, I'll show you this actually does work, is doing something called string interpolation. So we can remove all this, go back, and we can do a backslash, and then within parentheses, we can actually say num. Inside of this, you can also do math, which is really cool. And it's really easy now because you can actually see where your spaces are, so you don't mess up. And you can say my favorite number is now, not any other. And you can do plus 15. You can do math in here and it'll still work. Okay, I want to show you something about ints. We can have an int, and just to make an int, it should probably be a double in this case, but we're just making an int just to show you. Let's just say we have a balance or of money or something. If we're counting money, sometimes we can't, like, what is that number? It's so hard to read. We can actually have underscores to anywhere, and it will just ignore these underscores, and so we can just see this number easily. These underscores can be absolutely anywhere. The compiler does not see it as anything, it just as a filler. So if you do print this out, we will not see the underscores, we will just see the original number. This is just for us to be able to read it better. So next we have floats. Floats are very interesting on its own too. It's a double, but with only 7 decimals. We have a float, and we can see how many decimals. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's for 0 is 10. 1, 2, 3, 4, 5, 0, 9. If we try to print our float, we should have 7 decimals, up to 7. The same thing for our double. We should have 16 decimals. 16 decimals. And also another thing is, if you actually don't even have initializing it in the beginning, so if it's just like this or like this, it will automatically see it as a double in the very beginning. So yeah, so now it's just a double. So if you do want it to be a float, a 32-bit floating number, you have to actually say float. Next is calculations. I did want to show a little bit of calculations. So we can do minus, we can do plus, we can do division, we can do multiplication, and also remainder. I do want to explain what remainder is. It's not the decimal at only the decimal. Sometimes I thought about that in the very beginning, is actually how many remainders do we have. So if we do for instance, okay, I'm gonna do 10 divided by 3. Yeah, oh sorry, it'll say 3. If we do say this as a double, what do we get? 2.0. It's not even. Okay. Anyways, what if we do this? 3.0, 3.0. And so we're showing it as a double, not integer. There we go. 3.33333333333. Okay. That's good to know. Remember that, Ian. Yeah. All right. So in the beginning, I thought it was going to be 0.333333, as in the remainder. If I do remainder, I thought it was going to be something like that, but it's not. So how does it only work on integers? No way. Huh. That's interesting. Remainders only work on integers. Okay. So, yeah, it does 3, 3, 3, and how much is remaining? 1. That's where we get the 1. All right, let's go to our next thing. I did learn something. It only works on integers, the remainder, as far as I know. All right, now we have methods, and these are string methods in the beginning. So we have dot uppercase. I did make a testable playground of my number and my string, having a lot of weird stuff here. If we do my dot uppercase, I'm going to copy and paste things and just put it in here. This will convert all characters to uppercase. If we change our method to lowercase, it's going to change everything to lowercase. I will do it really fast, all lowercase. Okay, next one is very interesting. It's called trimmingChaaracters for whitespace. So whitespace is this stuff here. So all this right here, it's removing spaces at the beginning and at the end of a specific character. Also, what we need to do is actually import foundation. So usually at the top, what we do, we import our foundation, and this should run. Our spaces are gone. If for some reason you did have that, I actually will remove this after now because I don't care to show about white spaces now. Our next one is replacing occurrences. So it replaces occurrences with something else. Change our things. So we're choosing of great with awesome. So it'll see the word great and it will change it to awesome. Awesome apple pie. Our next one is contains. Does it contain apple? And apple. It returns a true or false. If it does contain the word apple, false. Do you know why? Because apple is capitalized. If apple actually is capital, all the way capitalized, it would return true because it does contain the word apple in full capitalization. So yeah, remember it is case sensitive. Next one is hasPrefix, just for fun. I love, because it's the prefix is the beginning. It checks if the string starts with a certain substring, true or false. hasPrefix, yeah, and hasSuffix the end, so it does the exact same thing, but it checks if, for example, whatever is at the end, if it's like my love, then it will see if it's turned true. hasSuffix true. Great. Okay, next one is actually interesting. This is called split. Split a string into an array using separator. So let words. If we did have to do this, okay, let's just do it by a space. So if we have it by a space, so every space in this sentence, it'll have it as a separator. So it'll be to, make, and you'll see how this works. It becomes into an array. So the first item in our array is I love to make. Yeah, it's all different items in the array. Let's just actually make this into a new array. So just to make this easier on me, last time we did split. Now let's do joined. And this will actually revert it, because now we're gonna have all these different characters or whatever joins an array of strings into a single string. So if you have an array of strings, it'll combine all of these and have a separator of whatever you want it to be. If it's a space, or it can be whatever of any specific substring. So I'm doing joined with a space. So it's actually just reversing this. Our array has turned back into a string. Our next one is prefix. So this one gets the first 5 characters, and it is 1, 2, 3, 4, 5. I love, without the E and everything else. If we do suffix, of the last 5 characters, it'll be 1, 2, 3, 4, 5, and just be love with the extra space. That is all dandy. We're going to go to our next one of computed property. So a property is kind of like a method, but they don't actually have the brackets of our I can't think of the word right now, but yeah, my num dot count without any parentheses. And if we print my num with because it's actually it can do my string. Yeah, what is it going to count? So this one actually will count all the characters in our string, and it has 44 characters in our string for this beautiful string. You can also do with my array. You can count how many items are in the array. So each individual word, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you do want to count every individual word in your sentence, you can with this odd method, but it still works. We can check if isEmpty. So isEmpty, it's an array. It's for an array or for elements. Is empty. We should get false because it is not empty. It is full of things. False. Without an error, because it is appropriate. It's in a collection of items. I have not explained arrays yet. I'll explain that later. Okay, and is first. This one grabs the first thing in our collection. This one actually does work now. I don't know what I did wrong. This is actually adding as a default if there's nothing inside of the array. So let's just print it. What an odd thing. And it should do the first thing as in the array. So why would we use first other than just doing 0, doing the first thing? As because maybe there's nothing inside the array, and it's just to check if there's anything, and if there's nothing else, we can have it into like an if else thing and do something else if it fails. It's interesting in its own. Okay. So let's do the same thing and try last, because it's also on our list. And we get cherry. Nice. Okay. And we have another thing that's related to strings, and it's capitalized. Let's go back to our fun string. We can do this as capitalized. And this is not a method because this is we're doing computed property, and we should have everything capital, the first letters of our word to be capitalized: I, capital L, capital T, M, and so forth. Okay, and next is we're doing is even is odd, so we need a number. Okay, I just realized that is even and is odd is not actually built into Swift. We can actually remove this. All right, So that's it. We did learn a few things. We want to recap. We learned about printing variables, lets, strings, integers, booleans, floats, and some calculations, and a lot of methods and computed properties. So thank you for today. Let's try to learn more. Keep testing like I was doing during this video, and learn as you go. Have a good one.